Yeah, we can start. We are live now.
Good evening, everybody. Welcome to this week's Socratic dialogue. Before we begin, please, everyone, let's introduce yourself.
Good evening, everyone. This is Nandini, and I'm the coach of Team Pattern Seekers.
Good evening, everyone. I am Shuchintika. I am also from the member Pattern Second.
Good evening, guys. I'm Vikrant and I'm from Pattern Seekers.
Good evening, everyone. I'm Vibhor Mehra and I'm the coach for the team Pi Pioneers.
Uh, yeah, good evening, everyone. This is Disha, and I'm a team member of Pioneers.
Good evening, everyone. I'm Abdullah Sadiq, and I'm part of Team Pi Pioneers.
Okay, we can start. Hello, everyone. So, my name is Shivam Dubey. I will be moderating this week's SD. So, this week's SD is about what is abstraction and why does mathematics require abstraction. So, one of the teams will introduce themselves. Start with the pitches.
Yeah, Team Pattern Seekers can go first.
Okay.
Well, before we start, here's why we chose the name Pattern Seekers, right? Well, something when it goes wrong, or even in our daily life, what we do is we make counts. It can be mistakes, it can be delays, how much marks lost. But what we observe is counting only tells us what that something happened in quantity, but not the reason that why it's keeping happen, why it's happening, guys. We do not get the reason behind it. So the presentation is going to explore that not how many times but what it is repeating, what's the pattern being followed, how we can identify it. And it comes from the concept from mathematics, actually, especially from Srinivas Ramanujan, who is known not by counting numbers, not doing quantitative, but by not noticing patterns which others missed. It's in his work. So moving to slide one. Yeah, well, we all start with counting, as I mentioned before, and how it only helps us once. But the real question becomes, why is this happening again? So Ramanujan didn't study one number at a time, right? He studied the whole behavior, that how numbers are behaving together. And that shift from counting to patterns is where real understanding actually begins. We can even implement it at our work. So moving to slide two. Yeah, limits of counting. So if the concept of infinity, right, you can't count it. And Ramanujan sir also worked with very large numbers where step by step counting doesn't work at all. It's not feasible. So mathematicians observe something which we call as behavior, right, instead of listing values. And real life, even in our work, it is very similar, because if a delay is happening once, you can count it. But if it's happening every month, you look for the pattern which is causing it. Transferring this it to Vikrant.
Thank you, Nandini. I would like to start with my when we were children, we were taught how to count numbers on our fingers, one, two, three. But have you thought about how we will see or touch negative numbers or fractions? But still, we treat them as real because they behave consistently. So Ramanujan trusted this behavior more than appearance, and the life works the same way. We can't see the stress, trust, or confusion that is happening around us, but we feel their effects every day in our work or in our daily life. That's why a good problem solver focuses on behavior rather than just what's visible. Moving on to next slide. Naming the unknown. We don't know something, and when we are in a problem, we tend to guess, and sometimes that makes it more messier because it's not necessary that your guess will land on the right mark or the correct answer. So in mathematics, there is a smarter way to handle this. We name it that unknown x, you might be familiar with, and in this you don't need to know the answer immediately. Just naming the problem is enough. It keep your thinking organized. We do this in real life too. When we say okay, there's a delay or there's a bottleneck, we name the issue, which creates the clarity rather than panic. And then thinking without knowing. Like you don't know the final answer, like you don't need the final answer to start thinking clearly. Ramanujan focused on relationship before exact values. He understand the structure first. In real life, we create a workflow of A to B. Like in this, you are not fixing anything, but you are understanding how things are working. And once the structure is clear, solutions come faster and works better. Now I would like to hand over to Suchintika.
Thank you, Vikrant. So coming to the next, that how pattern improvise ourselves. Like if we see some problem is happening again and again, that means we are tend to find the pattern, like what is the root cause of it, and we try to fit the pattern itself, fix the pattern itself, not just a problem. Like if I say if a person is delaying in his office time again and again, so office can take a strict rule on the every employee itself so that they cannot delay, so they cannot make unnecessary leaves. So this is the problem of fixing the pattern. Now coming to next slide. Yes, variable. Variable is a very common term in mathematics. So every time we are focusing on finding some solution in mathematics, we try to feed some x and y and then try to find a solution. So how it is important? So you know what the variable term itself saying, that is something is changeable. So it is not finding some value. It is saying that some value which is changing, but the structure itself is same. Like if we say in the Ramanuja's term, that the Ramanuja's number itself 1729 is a important example of this variable. Like here we are adding two values with their cube and getting 1729 itself, but you know the placeholder are changing. Like sometime it is 1 cube plus 10 cube, and sometime it is 12 cube, 9 cube plus 10 cube, and 1 cube plus 12 cube. So you know this is the way the structure is same and the variable is changing. So this brings us to the last point and the conclusion of our slide, that is the abstraction. So abstraction means removing extra details and focusing only what is important enough. So mathematics needs abstraction because counting doesn't scale, right? You can't solve every case separately, but yes, you can look the pattern, structure, and relationship, and which is working again and again. That is why we use variable, formula, and models. And this applies beyond mathematics also. Abstraction help understanding the problem and system, not just an individual problem. So that is why we call our the pattern seeker as our name. So we are using the solution, we are finding the solution by finding the pattern of the problem, so that we can make it reusable and rescalable. Thank you.
Okay, team Pioneers, do you have any questions?
Yeah, I have one question.
Mhm.
So in our work, we count the things like how many hours, spent, our number of hours we have spent in this project, and how many numbers of hours we have saved uh, to achieve this particular target. So, but do these numbers really explain the why? Uh, Means is the why behind it? Why the same issues keep coming back?
Can you elaborate a little?
Yeah, because in a first slide you show that counting tell us how many it is showing the numbers, right? But does it tell that why the same result is happening, or it's keep repeating?
I think it does in some way, right? I mean, the point is you are counting, let's say, a productivity chart that every day 4 hours of work we are not being able to, let's say, meet our KPIs. It's not being done. But we shouldn't stop in doing that. We should see the pattern, that what is causing the delay, why is the execution, let's say, not happening, what's stopping it. So it's a powerful tool to identify the pattern. So once the pattern is recognized, we can always take action or assess it in a different way. So yeah, data always helps. Numerical data, even in any form, is helping us to identify the pattern as whole.
Okay, it answers my question.
Any follow-up question, guys?
Yes, so a question from my side, that how do you like integrate the human factors like intuition, or as we say, gut feeling, into decision making, and that also if your data is telling you something else is happening and some experienced person in your team tells ki this situation I've seen somewhere and this is implication of something else and data is telling you something else. So how do you handle that?
So before, I just want to say, like, whenever you tell that a person who is out of his experience is telling that it is my gut feeling, or it is saying that something will happen because I face something. So whenever he is saying, or he or she is saying this, that means he or she is already experiencing that. This experience is already coming from some data. That's why this made it this intuition in his or her mind. That means in his or her mind also some data driven identification is already there, and he or she is trying to fit in this solution also in this system. So I think you understand it.
I got it. You mean to say that maybe the mathematical model is telling something else, but the algorithm or whatever data is fed
Hmm.
into his mind, it is something else. So whatever the intuition he is having or she is having, that is also data backed by some.
Yes.
Okay, got it.
Any
Yeah,
follow-up question, guys?
yeah, I have a question. So, can the application of abstract mathematical thinking sometimes hinder innovative problem solving rather than encourage it?
I think it can. See, everything can hinder or everything can cause trouble. Like everything has a negative and positive side to it. Just like the previous example Vivor mentioned, right? That what if there's a clash of opinions between the equations or whatever data gathered now, and when a person is a experienced person is speaking from like they have a gut feeling or they have intuition. So which should we go along with? So conflict of interest can be there, but still whatever decision we are taking, I believe it should have some sort of logic or some sort of rationale behind it, so we can justify it. More than the results, it's about how we are like the, as in previous SDs there was a topic called aesthetics of decision making. So more than the result is why we are making that decision, so it should be implemented here as well, that we are using patterns, recognizing patterns or recognizing all the things in implementing it. So yes, I think that would be justified.
Okay, so just to get some clarity, you mean balancing analytic approaches with creative thinking, right? To solve those problems.
See, even if I think mathematics is everywhere, patterns are everywhere. Even if it's too technical in analytics, or even if it's in creative sense. Um, so whatever you are making a choice, it shouldn't be like I just did it because for the sake of it. It should have some sort of justification behind it because you are working, and it should be meaningful, right? So patterns add meaning. Like imagine you are seeing something failing all the way and you are still risking it. So that's not something very intelligent to go ahead with, right? So you observe patterns, you see things working, and we just take the like go with it. So yeah.
Okay, I have a follow-up question, that why do mathematician trust structure or pattern more before doing full calculation? Because maybe full calculation is giving you more uh, like a proper result, because it is, you are able to counting the whole values, uh, a step-by-step process there, which the person can be follow.
But Disha, here the problem is, whenever you want to do the full calculation, it will solve only one problem. But if you find a pattern, it can solve a lot of problems which can happen the same structure again and again. So finding the pattern or finding the formula is more important than solving one problem itself. That's what I think.
Could you help me to understand what kind of patterns here we are looking for?
Uh, like uh, like if you think like from the mathematical perspective. So if why do you think the pattern like a plus b whole square, this formula invented? This formula can be, we can also square two numbers in different way. So this formula or the pattern is resolved in the way that is a square plus b square equals plus 2ab equals to a plus b whole square. It is a pattern that every two value, whenever they are added up and they are squared, they are giving this value. So mathematicians do what? They did the formula instead of doing the calculation itself. We can simply calculate the number, adding them and by squaring it, but they find how it can be simplified. So they find the pattern. So that is the, I mean, that is the problem they solved.
I think in
Okay.
short, it's just widening our scope, right? And also making us save some time and giving us more clarity. It can be implemented in our work as well. Like even
Yeah, I
if
would like to give one example, like to back it up. Let's say we want the square, we are calculating something, and we want the square of 103. One way is we can directly normally multiply 103 by 103. The other way is we can do, as Suchantika told, 100 plus 3 whole square. This is the structure way, and it will give the same answer, but in a faster way. I think that answer your questions.
Yes, it is.
Okay, I have a follow-up question regarding that. Eating your right hand and eating with your left hand is the same thing.
depends if you're
You said
ambidextrous or
you said that solving a question is the two-way thing. So eating with your right hand and eating with your left hand is the same thing.
Like in the end, the food is getting into your mouth. Like that is the answer we are
exactly. No,
getting.
no, I get it.
That
See,
can be different approach.
if assuming that you are a right-handed person, it's not like you cannot eat with your left hand, but using your right hand makes it easier, right? It's more organized because you're using it every time. Left hand you can do it, but it's difficult and sometimes a bit messy. Same with maths, right? When it's a pattern, when it's something organized, you can use your right hand or use that equation. But left hand, it can be done, but there can be a chance of errors creeping in or some spillage.
Okay, I got my answers. I'm satisfied right now. So any follow-up questions, guys?
Okay, I think we can move to second team. Also make sure, team pioneers, that your pitch is on time. Presentation. Can start.
Yes, so good evening, everyone. I'll be starting from the introduction of why we chose the team name as Spy Pioneers. Because Spy Pioneers reflects this name reflects our team's exploration on the groundbreaking work done by Mr. Ramanujan on you know exploring into the irrational numbers, specifically in pi. And this work highlights their pioneering approach, and we are deducing from that to understand complex mathematical concepts. So moving on to the first slide. Yes, from counting to patterns. So what we can infer key the counting is very basic, We count one, two, three. Can we have some more patterns from this? Can we arrive how eight is incurring just beyond, counting from one to eight? Eight can also be represented as two into four, or it also can be represented by two raised to three, right? So as we said that Ramanujan's few numbers are just patterns that speak to us, and we can also dive deep into them, revealing their secrets. How can numbers arrive simply beyond just one way of getting to them? Then we have this limits of counting. Ki while Ramanujan explored the sums to infinite series, this was very much non-traditional, because nobody went and dived into that side. How can we count what is infinity? So Ramanujan, by his tricky ways of calculating the series or sums, he got to know that when we do this half plus half of half and then half of half of half, we can arrive basically at minus 5 by 12th. Okay, so how was this possible? This was also possible by observing some trends that numbers follow. and which were not visible clearly with the traditional methods. So this was a limit that was broken by Ramanujan. Continuing forward and handing over the slide to Disha.
Yeah. So in mathematics, we work with the things like fraction, which you can't really see them physically, but they are essential to make a right calculation. So in a teams, it's kind of similar. Like things like ownership, it don't show up directly. Like they only show when daily reports are missing or reviews becomes irregular. So when those compliance stop happening, it's usually not a process issue. It's a signal that underlying structure isn't working well. Moving to next slide. Yeah. So in mathematics, when we don't know the number, we guess it as X or we name it as some variable. So in real work, the same thing happened during reviews or team discussion. We don't, if we don't know exactly why performance dropped. So instead of assuming things, we treat these as a gaps. So that's why decisions are based more upon pattern or relationship, not upon assumptions. Moving to next slide. Yeah, so Ramanujan could work with equations without knowing actual numbers. He focused on how things behave, not just as on values. So in real work, we often face a similar situation. We don't have a complete data, but patterns still show up in weekly reports or other team execution. So instead of waiting for perfect clarity, we look at these gaps to understand where things are breaking down or slowing down. Over to you, Abdullahi.
Okay, thank you, Disha. So, power of patterns. Now, power in maths are patterns in maths are powerful because they work for any number, big or small. So it's not the number themselves that matter per se, but the relationships between them. So formulas show us universal relationships. Like take for example, in a business, a good pattern or process work in many situations. It helps you adopt and grow even when details change. So patterns make scaling easier and more efficient. And for example, in maths, the area of rectangle is length times breadth, and it works for any size rectangle, right? Okay, so moving to the next slide. So what is a variable? Now, a variable can represent any number, not just an unknown. It helps us create general rules that work in many situations. So, and this is important in math theory and real world planning. And let's say in business, variables stands for things that can change like cost or demand. Using variables help us build flexibility. Like take for example, in the formula profit, it's equals to revenue minus cost. So that cost is a variable. It can be any amount. And you can plan for, in business, you can plan for costs going up or down without changing your whole plan, right? So this flexibility helps us stay ready for market changes. And in conclusion, maths is not just about counting, it's about seeing patterns like 2, 4, 6, 8. Now, that is a pattern that helps predict the next number from, you can see from that. So Ramanujan showed us that maths is full of potential and possibilities. By using patterns, variables, and abstract thinking, we solve hard problems. In business, this means looking for the big pictures, not just the details. And thinking this way helps with long-term growth and smart scaling. So math thinking turns confusion into clarity, basically. Thank you.
Okay. Question box is open.
I have a question. Abdullahi told that variables generalize the relationship. Can you elaborate more? Like what type, how variables can generalize relationship? Because it is unknown, it is changing. So how it can generalize?
Yeah, like for the example I give you with profit equals to revenue minus cost, right? So you can see cost is the unknown there, right? And we said that variable is not just an unknown. So even though cost can be anything, In business, when it comes to business, you can plan for costs going up or down without changing your whole plan. So you see where the distinction comes in. Yeah.
Okay, it answers my question.
Any more follow-up question?
I
Another
have
question I Okay, Vikrant, you go ahead.
how can we shift our problem solving to focus on how the system behaves and rather than like only what is physically visible or easily counted things? How can we shift our problem solving?
Like we have metrics for an individual person. Like we have this thing called daily plans and daily reports. We implemented this policy that we'll be able to track how a person is performing each day with daily plans and daily reports. Okay, so we told everyone for this that everyone has to, fill in their daily plans and daily reports. So we are just implementing one thing for each person and everything is doing that thing. So we can track for individually and we can use some AI software key, please at an enterprise level or at an organization level, you can check in the daily plans and daily reports and you can tell us where are the bottlenecks, which team is not performing well, which team is performing well, and that can give us the metrics from a daily plans and daily reports. This is also like a system hierarchy, or you can say like a tree that has a top level, has a mid level, has a bottom level, and top level is able to view the bottom level or maybe the lower level through systems. Does that answer your question, Vikrant?
How we will be shifting towards the problem solving part?
See, we can reduce the bottlenecks very easily once we have, daily plans and daily reports. Once we have what were the objectives of those people by their daily plans and what they have executed by the daily reports. We also have weekly plans, weekly reports, and out of those objectives, how much have been executed, which teams are faster in executing, which teams are slower in executing, how much percentage has been executed, what are the bottlenecks that have been faced that are able to be seen by the upper management or maybe the person who is keeping the systems in check. Maybe if I'm in the HPF lab, I'm seeing ki, which team is executing their task very at a faster pace or maybe at a lower pace, which team is having bottlenecks, so which are the people they are not complying with the task and the rules and regulations, so we can have a check for that. This system has been implemented for each person and we at an maybe the team lead or the micro lead that is able to handle all their team members problem, and then we can connect to the micro lead or the team lead and then we can gather the information from there.
Yeah, that answer my questions.
Yeah, okay.
Any more follow-up questions, guys?
I have one. Previously, you told in the limits of counting slide that how infinity works. But I want to know more about that how we can actually implement those infinity concept in our work, so that we are not bounded with counting only.
Okay, to answer that, Suchantika, I must tell you, ki, we are in a system that works very dynamically. Trends are changing and objectives are changing and the demands are changing. The trends that we follow or the series that I showed you was very, static. That if we are counting an infinite series that, goes from half to half of half, then half of half of half, that is very static. That in a square, if you have to calculate its area maybe, or you have to calculate the sides, that is very static. And in a system or at an organization level, our system is very dynamic. It is changing with a lot of factors. So we cannot rely on a static system or a static formula or a static algorithm. We have to keep in check all the dynamic factors that that if our team needs more members in CRM lab, we can hire those, and the objectives would be changing. This system is very dynamic, and whatever system is lagging behind, we need to tackle that first, not entire thing at the same time.
That means adapting ourselves with different solution, like the infinity number of problems.
Yes, like Sina, it's not just playing with all four sides at the same time. Whichever side is, getting weak right now, we have to tackle that. We have to keep in check ki all four sides are working in sync. Not, ki we are just focusing on one thing. Yeah.
Are you
Yes,
Okay,
satisfied,
that's my
guys.
answer.
Santika?
Yes.
Okay. Any more
So we can
follow-up questions,
start with the
guys?
reflection. We can start with the reflection. So do you guys have any more questions? No? So please share a reflection. We want at least 3 reflections. Who will go first?
I would like to go first. Like in mathematics, there are some negative numbers, fractions, or infinity that we can't see or touch. Like in team, when you're working with team, there are other factors that are affecting that also, like the trust you are having, the feelings, or what is your mood at the work that you are doing. That also matters a lot. And I got the understanding of that today. That also matters.
Yeah. So my key takeaways are like from today's topic, what I have learned that like the most of the problem in the team, it don't come from lack of efforts, but it comes that when we are not have that understanding that what actually happening beneath the system or beneath that particular surface. So just like as we have discussed in a mathematics, where we name some unknown things as a x or some variables. So in the same way, instead of reacting to someone individual mistakes, it's a kind of way of thinking which is helping us to identify whether the same issue is a actual ownership or system designing or process designing. So because once the pattern is clear or that particular problem is can be detected, so then accordingly the decision can be delegated or the reviews can be happened. So this is a one key learnings which I've got.
Are you satisfied, Santika?
All the SD participants. Um, so you have participated in this week SD. So please share a reflection. Be proactive, guys.